So we've got a bunch of Riemann sum approximations using right hand. So these are right Riemann approximations to evaluate the integral from 0 to 1 of 1 over x within subintervals. So we're getting more and more subintervals and getting a more and more accurate value. And we are wondering which of the following statements should describe the limit of the Riemann sums as n approaches infinity. Okay. So what are our choices here? It's less than 10, it's a finite number greater than 10, doesn't exist because it does not approach 0, doesn't exist because it's a sum of infinitely many positive numbers, or doesn't exist because 1 over x, the integral from 0 to 1 does not exist. Okay, all right, so looks like just at a quick glance, we should know just by really quickly doing the integral from 0 to 1 of 1 over x dx. If you do that integral, right, if we do the limit as a approaches 0 from the right of the integral from a to 1 of 1 over x dx, that gives you natural log of the absolute value of x from a to 1 with a limit as a approaches 0 from the right, which gives us the natural log of 1 minus the natural log of 0 from the right. And we know that this does not exist because can't take the natural log of 0. Natural log of 0 coming from the right-hand side is negative infinity anyway. And the opposite of a negative infinity would be an infinity, and clearly that doesn't exist. And so the answer would be this one. Because that integral doesn't exist, that means that no matter how many subintervals that you try to put in to make a right Riemann sum, you're just going to keep getting more and more and more and more area underneath that curve. And the values of those Riemann sums are just going to keep increasing forever. Slowly, but they will keep increasing forever. There's no limit on them because this diverges. This one, sort of says that doesn't exist because it's a sum of infinitely many positive numbers, but a sum of an infinite number of positive numbers can be finite, and this is not finite, so clearly this one's not the choice. And 1 over x sub n times 1 over n does not approach 0. Let's see the limit of the Riemann sums of that. I mean, as either x or n was to be approaching infinity, if n approaches infinity, this is going to approach 0. So it's not this one. And yeah, I mean, those don't make any sense because it's not going to be a finite number because the integral diverges. So does that make sense, Dan? All right. Any other questions from the 2008 test? All right. So if somebody's got a question on the 2012 exam, since nobody's saying anything about 2008, we can jump around to that. So let me pull up that one and throw the problem up here real quick also. Uh, 17 and 27. All right, so for number, oh, geez, sorry, my computer's having an issue here. It's great to be back in the classroom where everything just works perfectly. All right, so for 17, we are looking at 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial minus x to the 6th over, sorry, 7 factorial, with a common term of negative 1 to the n times x to the 2n over 2n plus 1 factorial. This looks very, very similar to the series for what function? Looks very similar to the series for sine x, doesn't it? Except that sine of x, these would be, this would be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on, right? It gives us an x to the, right, it gives us negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial, right? That's what sine x is. Do y'all agree with that? That's just one of the ones we should have memorized. And so we should note then hopefully that this is almost exactly the same, except we've dropped the plus 1 here. So if we're going to drop the x to the 2n plus 1 and make it x to the 2n, we just got to divide that by x, and that'll get rid of this 2n plus 1. And so effectively what we're doing is we're just taking sine of x and then dividing it by x, right? If I take each of these and divide it by an x, I'm just going to get 1 and then x squared over 3 factorial, x to the 4th over 5 factorial, and so on. So we should be looking at sine of x over x. Does that make sense, Adrian? And everyone? All right. Let's see. And then you were also asking about 27, right? Let's see here. All right, so for 27, we're looking for values of p for which both of these series will converge. Okay. For which both will converge. Okay, so the second one, we're looking at this one. This should be, this is just a geometric series, right? Our common ratio should be p over 2. And so we just need to take p over 2 and put it between 1 and negative 1, which should give us, this will converge for everything between negative 2 and 2. And then for this one, we know that this is, let's see here. How are we going to do that one? Yeah, that one should just be like the, it's not quite the P series test. So I guess we'll have to do a ratio on that one. So we'll look at the limit as n approaches infinity of 1 over n plus 1 to the 2p over n to the 2p, sorry, 1 over n to the 2p, which is going to give us the limit as n approaches infinity of n to the 2p over n plus 1 to the 2p as n goes towards infinity. Those, that's inconclusive. Let's see here. Think about that for a second here. What's another good test we could use for that one? Well, I guess I should just be able to, I should probably just be able to think about this one a little bit. This becomes the harmonic series if P equals 1/2, then 1 over n to the 2P equals 1 over n, which we know diverges. I guess we should be able to, all right. Yeah, I don't know why I was thinking we can't use the P-series test for this, but you can. So this then becomes, we need this exponent down here in our denominator to be something greater than 1. And so we need P to be greater than 1, which means that P needs to be greater than 1/2. And so that should just tell us that P needs to be greater than 1/2, but less than 2. So that should be our overlap, which should be choice C. Any questions on that one? Oh, people have been saying things in the chat. Yeah, it is P-series. You can use P-series. I don't know why right off the bat I said you couldn't. I don't know why I said that you couldn't, but it is P-series for both of you that were asking me why you couldn't use P-series. I don't know. It is, and you can. Any other questions from, I guess, from either of those, the 2008 or the 2012 test? So we are given 2 polar curves, 2 cosine 3 theta, and r equals 2. We want to find the sum of the areas of the shaded regions. So probably the easiest thing to do here is find the area of the full circle. So the full circle should be pi times the radius, which if this is r equals 2, that's a radius of 2. So that should be 4 pi for the full circle. And we just need to subtract off 3 petals of this rose curve. And so to figure out what 1 petal of this rose curve is, or we could even just do half of 1 petal of this rose curve, because we know that if we start here, if we let theta equals 0, that's going to put us right here. And then the first time when 2 cosine 3 theta equals 0 will be back here, and we can multiply. So we can multiply by 2, because that's going to be half of one of these petals. So we have half of one of the petals, so multiply by 2 to find the full petal, and then multiply by 3 for all 3 of the petals. So that'd be when does cosine of 3 theta equals 0. And that would be when 3 theta is equal to pi over 2. So when theta is pi over 6. So it should be the area of this, which should be 1/2. And a lot of you guys, when we do polar area, have been forgetting that it's 1/2 r squared. So it should be 1/2 the integral from 0 to pi over 6 of r squared to cosine 3 theta squared d theta. And I don't offhand know what that is. My graphing calculator is somewhere in my bag on the other side of my classroom. Anybody happen to know what that comes out to be if you integrate all that, and 4 pi minus 3 times that integral. Probably C or D. It's definitely C or D. That's way too much. That's way too little. Does it come out to be C or D? D? Okay. But that's the right setup. Does that make sense there, Nick? Cool. Other questions?